Okay, here goes. This is a Linstead EHT supply type S2 from 1970, give or take a year. This is something that has been in the school storage cupboard for who knows how long, and now they want it up and running again, but they don't trust something that looks so old. So I checked it and I can get it running, pretty much. As you can see, this is up for 6 kilovolts output. It does actually work, but it needs a bit of work inside. What surprised me is firstly how old this is. That capacitor there is dated September 69, which means this thing is 1970, give or take a year. Now, when I think HT power supply from 1970, what I'd expect to see is a great big transformer, massively step up, and some kind of crude shunt regulator, and some current limiting resistors on the output. Oh no, not like this. The thing's a switch mode power supply built out of a valve. It does the job. It's weird for the time, but if it works, it's actually, I believe, a flyback topology with the added output stage here, which is ignore the top two resistors, they're just a meter. Yeah, it's a charge pump, voltage multiplier. That's how it reaches 6 kV. What also surprised me is just how safe this thing is. You open something of this vintage and you expect to be a death trap inside, but no, this is very safely designed. Maybe because it's made for the educational market and they don't want to electrocute any children. Could be. Power side wise, it's pretty much you'd expect from valve era equipment, transformer, and an RC filter, 3 caps, 2 resistors, which I don't like, and I'll come back to why I do not like that later. It did have this weird thing inside it. This is the Rectifier Diode, only a half-wave rectifier. So I would probably have gone for a full-wave rectifier, and that wouldn't have needed so much filtering, or even a center tapped. But I'm guessing the reason is this thing here, because if this is the kind of diode that 1970 had available for rectifying at this voltage, I'm not surprised they only wanted to use the one of them. I don't really trust it because it's old and unfamiliar, so I've put in a modern one. This thing draws very little current. The case is connected to ground. It is also connected to the transformer secondary. So all of the electronic switching stuff is connected to earth ground, which is good. It's good for EMI, I suppose, and it's these days is a nice safety thing because it means that a primary to secondary fault in the transformer is just going to trip the RCD plug I'm putting on the end. So even if the insulation in the transformer fails and it is 50 years old, no one dies. Again, caveat I'll get to. Speaking of which, the insulation is good. I have checked it. 15 mega ohms is as high as 20 mega ohms is as high as my meter will read, and it's still reading nothing interwinding. So there's good insulation integrity. All the windings are intact. And take a look at the thickness. Ow. Yeah. See these really thick second layer? Again, I'll come back to that later. But that is really nice and thick. Right. I don't know how this electronics works. It works. That's all I know. That's all I need to know. You turn the dial, the meter moves, the voltage varies. I'm not going to try to ask how. The actual high voltage output is kept isolated from the rest by this transformer here with a nice big air gap. This is a non-conducting insulating winding thing it's wrapped up on. Oh, there's bits of paper in between these two halves of the transformer. Maybe it needs a very specific thickness air gap. The high voltage board itself, voltage multiplier. All these resistors, they're all in series. They are 1 mega resistor, and its only function is to connect through these winding wires here to the meter. And if you look closely, you see that these cables are actually screened and connected to mains ground. It's very nice of them. There is, however, one design flaw, and it is this. This is what was the filter capacitor. You might notice I've replaced it. 3 caps, 350 volts, which I've replaced with 3 caps, 350 volts. Close enough capacitance. Then I discovered that's a lie. Because yes, when this thing is working, 350 volts on those capacitors. What you can't see is the secondary has a resistor tucked right up inside the transformer. And that resistor drops a lot of the voltage when it's drawing current. Which it doesn't when it's turned on because it's a valve device. And it takes a minute for the filament to heat up. So when you turn it on, this capacitor and this one all get charged up to 400 volts. 50 volts higher than the original or my replacement capacitors are spec'd for. Once the filament heats up, it draws current, then they drop down to about 320 and all is well. So every time you turn this on, you're overcharging the capacitors and you're just hoping that they don't explode on you. So now I've got to get these out again. I've not even secured them physically in, which is at least one helpful thing. They just flop around because I've not actually put a frame in to support them yet. And I've got to get 400 volt capacitors, and I've got to install them all over again. So thank you, 1970. I don't think that's a mistake, because anybody who can design a valve-based flyback topology switched mode power supply is not going to make such a rookie mistake as failing to account for the filament warm-up time in specifying their capacitors. No. I think this was a cost-cutting measure. Probably final thing to design. They're slightly over budget, so they look, how can we possibly save a few pence off the cost of this thing? A couple of quid. And they come up with the idea, why don't we just underspec the capacitor slightly? It's only going to be a little bit overcharged. It'll only be for a minute. It can probably take it. Well, it did take it, so I'll give them credit for that. But I am not so trusting in my caps, so I am going to have to get some new ones. The only other safety concern on this is what I had was this output here. This is the auxiliary output for 6.3 volts AC for driving filament heaters in valves. Handy. What I really like, that really thick insulation I mentioned, that is what it is insulating. So they have massively over-insulated this output from the mains as a safety precaution, I suppose. It's very nice of them. The actual filament heater for this comes from a different place entirely. It's actually a winding on these two terminals. Yes, I have discharged these here and here. So, yeah. Easiest way to make sure that there is absolutely no risk in the event of this transformer failing is simply to disconnect the auxiliary output. Although even if it did fail and somehow mains current made it to these and someone touched them, it's just going to trip the RCD. So it's better safe than sorry, and I don't think there's going to be any use for a 6.3 volt AC output anymore. who has valves in their practicals. Oh, 10 minutes. Right, I think I've made this one long enough. Also, I am hot and sticky and sweaty. And if I stop recording, I can turn my fan back on. Okay, is there anything else? No, I think that's it.